All right. Hello and welcome. It's my privilege to introduce myself, Ryan Couch, CMO of NetBrain. I'm here with my colleague, Song Peng, SVP of Engineering, leading our engineering team. And we are proud to speak to you today about AI and automation and how it's solving the toughest network challenges. Thanks again for taking time here at the end of the year. We're excited to debut our Release 12. NetBrain is 20 years in our innovation, the gold standard of network automation and operations. And we're excited to welcome clients and those checking out NetBrain for the first time. Again, hello and welcome. I'm Ryan Couch. Happy holidays, Merry Christmas, Happy Hanukkah, Happy Kwanzaa to everybody joining. And again, we're excited to debut and talk through how AI and automation is solving the toughest network challenges, how enterprises are shifting from reactive to proactive network operations, right? We're here at the end of another year and we're all looking at those final end of year numbers, end of year purchases, end of year security audits, et cetera, and then planning for next year and looking at how we want to do things differently and perhaps gain efficiency in so many areas. And of course, the network drives your business. And the network is often the last place to look for making those proactive efficiency changes. So excited to welcome you again. In a moment, Song Peng is going to go over some of the finer use cases, but just want to remind you about who NetBrain is. Founded in 2004 by Lingping Gao in Boston, millions of network devices managed. Over 1/3 of the Fortune 500 trusts NetBrain and our leading no-code network automation platform for hybrid network visibility and operations. 11 patents power our solution, and we're very excited to continue to grow our customer base and their satisfaction in overcoming the toughest challenges. I was just at the Gartner IOCS show last week and getting on the road, talking with our customers, talking with prospects in the field, asking them, what are the toughest challenges? What are you experiencing here in Q4 or throughout the year when it comes to network operations? And here's what we heard. Oftentimes, organizations lack end-to-end network visibility. They talk a good game, right? We're doing our best. We're trying to understand where we're at, but there's a lots of myths in the network. Why is this doing that? Hallucinations, some might call them. And it's leading to surprise outages, performance problems, security issues at any time, right? A lot of times at the end of the year, folks say, it's time to freeze the network. We can't afford any more changes lest anything happen to take our network down or even give us performance problems at this critical time. Often we talk to folks who are constantly reacting to urgent crises. They're unable to be proactive in their planning, prevention, and security, and they got a small team. Hiring a larger team is not an option. They claim they're responsible for network upgrades. That small team has to do all the config changes. It's a time-consuming, manual, error-prone process that presents critical vulnerabilities. Of course, troubleshooting is top of mind in network and application performance. The network team or the NOC often gets, the raw end of the stick and gets blamed, right, for all the performance problems in the organization. And there's little to no network documentation to address these issues and to understand why the network was built a certain way. Oftentimes, the original architects of the network are long gone, and the leadership has changed hands multiple times. And it's tough to understand why the network is reacting the way it is. Security investigations are slow and manual. Again, a serious business risk. But my friends, there is a solution. We're very excited to debut, to talk through Release 12, NetBrain Next Gen Platform, a new era of observability into action, right? What's the good of looking at something if you can't take action with the insights that you're getting? And imagine that with AI and automation. I know what you're thinking. AI is a buzzword, right? A famous comedian once said, artificial intelligence, it's an oxymoron, right? How can this be legit? And of course, we know that AI is only as good as the intelligence it provides and the problems that it solves with human action, right? AI by itself can't help, but human-led, human decision-making with context around real-time intelligence, that's where the magic happens to advance actual business outcomes. So combining AI, that machine intelligence to advise us on our network, to give us insights into why it's not working the way it should, and then summarize results and then put it into action with automation, that human intelligence and that context with playbooks at machine speed, again, on a full dynamic network map. So excited that NetBrain has been the pioneer of the digital twin, live dynamic mapping, not a snapshot, not a third-party integration, all together in one place. Imagine if you could replace in 2025 70% of your MTTR, mean time to resolving an error, with 70% efficiency. What could that unlock in your team and your organization? So that's what we're here to talk about today. How could you automate ticket handling? 95%. So many of those same tickets and troubleshooting happen over and over again. We have a deep integration with ServiceNow, a robust integration that updates NetBrain and the CMDB within ServiceNow when a ticket is resolved. Imagine if you could reduce those trouble tickets by 50% just for visibility, being able to analyze the statistics, identify deviations from day one, day two, and the drift from the norm. And then imagine if you could gain productivity for end-to-end visibility in your full hybrid network. We're talking public, private, on-prem, cloud, whatever your network status, productivity gain from end-to-end visibility. A few more that we're seeing in our enterprises today. Eliminating 90% of human error related outages. Of course, more than 70% of data center outages are caused by human error. Imagine if you could standardize and automate change management, gain what we call triple defense. Before a change, understand the impact that change will make. During a change, understand what's happening while it's being made. And then after the change, being able to report on it. And all of this in Release 12 with the ability to reverse engineer your network, understanding its state, its features, and its intents at all four layers to understand why a change is going to affect the things that it does and make sure you prevent that human error and those security outages. Speaking of improving that application availability, even if you're not down, you want to make sure everything is performing at peak levels, especially in critical times like the holiday season. Of course, security top of mind for folks. Imagine if you had a playbook for NIST compliance to match your current configurations to a playbook with AI and automation with a human driving the action to define and verify those security policies. We have many customers improving their network security 25% or more year over year. All of these pain points are helping organizations transform their network operations from reactive to a proactive workflow. And in fact, many times we look at these in four pillars. So look with me on the left side here. Of course, we want to have that dynamic visibility in the mapping. We want a single source of truth inventory. Remember I talked about no documentation? Imagine if you had one-click documentation, and then you had AI to actually connect you and summarize key points of that documentation, or perhaps send an email to an executive summarizing the key points. Those dashboards are super critical. Number two, assessment and observability. That continuous, always-on assessment of your live network. Again, those observability dashboards, green and red, where there's areas where we can grow, where there's areas where you need to auto-remediate. Imagine one-click auto-remediation. We're going to hear more from Song a bit about that. And number three, auto-diagnose. How many of those trouble tickets take manual, slow process time for your limited team members? Imagine if AI and automation could auto-diagnose a bulk of those tickets, those trouble tickets, reduce MTTR, reduce the time spent, and then of course, power remediation. And then number four, I mentioned change, right? Many people are freezing their network at the end of the year. No changes. We can't afford any downtime. Imagine if you knew your network so well with reverse engineering that you understood its golden configuration. In NetBrain, that's unlocked. With Release 12, you can now predict exactly what will happen before, during, and after a change and secure that to ensure there's no drift. And if there is drift later, you can always auto-remediate to go back to that golden config. My friends, this is AI-powered automation to accelerate those business outcomes. But let's dig into more of the engineering side of it. I'm going to stop sharing my screen. And again, thanks everybody for coming on the call today. I want to invite Song to go ahead and share his screen. And while he's bringing that up, again, I want to thank Song for all of this. And for those who have questions, of course, please leave them in the chat. I'm very excited to welcome Song Peng. Thank you so much.
Great. Thank you, Ryan. Welcome, everyone. Today's a very exciting day for us here at NetBrain. And my name is Song, and I lead the engineering teams here at NetBrain. And I have the privilege and very excited to introduce NetBrain R12. And in this particular version, we are very excited to unveil a couple of new, very exciting things. at the forefront of the fusion of automation and AI. So let's get into it. So NetBrain at its core and through many different years of innovation, we wanted to create a no-code automation platform where all of our customers using their network, their knowledge, and their people is able to use NetBrain to use automation in their daily workflows. So what it could look like today is network engineers for every incident, every change, every assessment, everything that they do on a daily basis, they can use NetBrain to have access to end-to-end visibility, auto diagnosis through automation, making every single problem resolution faster, making safer changes, understanding the impacts of the changes that are being made, and then also being proactive in looking at across your entire network, fill in the gaps of observability so that you can identify issues before they happen. And we do this through the wonders of two things. One is the discovery of the network into a digital twin, where we talk about how we can take any network and develop it into the 4 layers of digital twin from device, topology, flow, and intent. And also, we partner with a lot of our customers in building their own knowledge of how to troubleshoot, what to assess, their network golden configurations. Through the no-code automation, build that into automation so that all the network engineers within the organization is able to use it for their daily workflows. In R12, what we seek to achieve is innovation in all of these fronts in a couple of ways. First, we asked ourselves is, can we, in addition to enabling our customers to build their knowledge into automation, can we use the network as a way to reverse engineer lots and lots of different things into automation? So now we can mass produce and create lots and lots of automations as a starting point and get customers going. The second thing is, can we further simplify the user interface with generative AI? And this is very exciting for us as we believe that the fusion of automation and AI brings upon a vast number of different improvements so that the customers are able to use the automations much better. So we coined this as a human interface to the machine intelligence that have access to all the automation digital twin that has to offer. And last but not least, we thought about if we're able to provide network assurance, proactively looking for potential issues, troubleshooting faster, can we tie this into proactive remediation? So we can go from true observability to also remediate the issues using automation itself. So this is a really exciting version and release for us that it's a culminated of lots and lots of work from our collective team, partnering with our customers and hearing everyone into how do we actually make our automation platform more powerful and simpler and more accessible. So first, let's talk a little bit about reverse engineering. Since NetBrain in 2021, we've talked about how we encourage and we build our platform to not only manage the devices, the 1,000 devices in your network, but really to try to manage it in terms of its intents. So each one of these devices have lots of configurations, lots of states that are natural to it. If we can manage the devices, not simply the up, down, or the health of this device itself, but if we can understand the intents that each device represents in terms of its configuration and state, we can provide that next level of observability, but as well as insight and intelligence that we can use in troubleshooting. So in 2020, since 2021, we worked on how do we build all of this with a no-code automation platform within the first generation of our technology. But when we went back and said, well, can we do better? In R12, we want to introduce the concept of reverse engineering your network into your automation. So the beauty of this is that each device, almost similar to a fingernail in a human body, carries all the DNA that the human would need to have. If we can take any devices, set of represented devices, understand the features that are deployed and implemented on these devices, it's almost like if we understand the DNA of the network device itself, represented by these features. And if we can furthermore reverse engineer those features into its config and into its state, what we can do is really accomplish a discovery of network intents in addition to all the no-code platform, the build of the intents from your knowledge. So what we wanted to do is to see if we can take any device, reverse engineer through the features into its golden configurations, golden states. So let's dive in a little bit of how we want to do this. So let's start with config. So really reverse engineering configuration is simply, we wanted to think about it in terms of three simple steps. The first is if we can take any network, and any network is going to be different, it's a snowflake, and networks are configured differently. If we can reverse engineer into multiple different sets of types of designs configuration, so this could be your network-wide designs, such as your access security, logging, licensing. It could be your failover designs, like your firewall redundancy, internet routers, data center switches, or it could be your key local designs. If we can reverse engineer these designs and configurations and answer three fundamental questions. Number one is, how many variations of configurations exist currently in your network of the said design? So in this case, for example, we are able to decode NTP server, and we found there are 5 variations, right, in the network. The second question is, what devices currently has each config variation? So it could be your North America devices, could be your EMEA devices has a set of variation, right? But this is using a data-driven way to help you understand what exists in your network today. And then the third and most important step is allows you to select which is golden. So which one of these variations should be a golden variation for a set number of devices, and we allow you to set that. So as you can imagine, once we start to decode lots and lots of these types of configurations and set these parameters, what we can then do is start to identify some day one issues. So identify that golden configuration for North America should be 10.10.10.1, et cetera, et cetera. We can now apply this to the rest of your network and start to understand if any of your configurations or your devices already has a config drift or deviation from the golden configuration. Now, within our customers' environments that we've been working to beta test this particular functionality, we found lots and lots of things. And this is, a lot of it is networks are built from decades of knowledge, hundreds of people, and lots of changes in a given year. And it's very, very difficult to be able to maintain all of the golden configuration as well as the drifts that are happening. So this was a very big eye opener. And then lastly, once we start to identify these day one issues and start to remediate them, we can now also build that into automation to prevent it from day two drift. So now that we're able to find these issues, correct them, now every single time when you're troubleshooting, you're able to see these deviations, or as you're making changes, you can proactively know if any of them are actually violating a particular configuration rule from before. So this part is very exciting. The second part of it is coming back to using features to decode the network. We can also use a very similar method to decode the states of a given network utilizing its features. And we also wanted to abstract this into 3 core steps. First is very similarly is to decode or reverse engineer your network using feature discovery to understand all the different features that has been enabled in your devices. While we do this, we're answering 2 fundamental questions. Number 1 is, what existing devices have these features? And what feature instances, so in the case of HSRP, is where it's defined by the group and its VIP, are these devices belong in? So now we can naturally cluster these features into the devices that have the same type of configurations that are attached to them. Now, what this allows us to do is the second step, which is now to forward define automation logic. So now we can define through an even simpler no-code platform is to help us understand and build automation that are built up of these devices that we found with said features. So in the case of HSRP, for example, we can do a lot of very, very interesting checks, such as simply maybe starting with whether or not the state has changed in any of the HSRP devices. We can also start to look for much more complex, interesting things like, are the ACLs between the 2 HSRP failover neighbors, are they consistent? So did I change one ACL and maybe forgot to change the other? And also I can start to do some interesting things like heartbeat checks of having one device ping the other to make sure that there's reachability. And what this allows us to do is once these automations are created based on the features that are understood from a network, we can now use this as troubleshooting on the map, use it during a change to understand what potential impacts that a change could have before the pre and post check. And also we can build these into big network-wide observability dashboards so that we can understand across the board, across all the different golden configurations, as well as the golden states that are understood from the network itself. So enough of slides, a lot of very exciting things, but let's jump into the product to actually to quickly see a demo. So let me jump into the NetBrain product quickly. And actually, let me start again. So let us jump into the NetBrain product quickly. And first and foremost, let's build a map, right? So let's say that we're maybe troubleshooting something, we're trying to understand something, and we're going to basically build a map of a potential application path. In this case, it's a web application, and I'm building a map. And this is the path map that everyone knows and loves. We're able to go from an IP-A to IP-B and be able to look at all the devices in between it, and as well as looking at all the view details, the device details that we see, and looking at the path details of understanding exactly what drives the next hop. So lots of things that we have going for us. Now, the first thing is, let's open into the intent. And you'll see in version 12, we have two new tabs. The first is what we call a golden configuration tab. So immediately, what we're able to see is a configuration of US LAX SW3. And I can see that there are 5 alerts and 23 greens on this particular device. And this is coming from 15 different rules that the network has reverse engineered from your network, the product reverse engineered from your network. So if I click this little button here, I can see all the different rules. So this could be from spanning tree configuration rule, VLANs, QoS, HSRP. Let me kind of scroll down just a little bit and see whether or not we see anything from different types of alerts that I have. So I can see that I have a couple different alerts here. So one of them is a VTY ACL configuration rule. I can click into this now and see this is the current configuration. And then this is the golden configuration. And very quickly, you can see that there is an extra access list 17 line that I provided that's not in golden. Very helpful. I can also see that, for example, I have my telnet enabled. So I click into here and I can see that while the golden should be transport input SSH, in this case, I have transport input all, right? So telnet is enabled, that's not good. I can furthermore look into all the different types of alerts that across all the devices that I have. And I can look into seeing there's 9 devices with no telnet enabled or telnets enabled, 6 with a VTY ACL configuration rule that are faulty. So I can click into any of these, click into them, and they'll be able to actually jump to the configuration itself. The second tab that we now have access to, something called golden intent. So if golden config captures all the current golden configurations, as well as the deviations that you have within it, the golden intent would look at all the different states of the network. So in this case, I can see that I've reverse engineered or discovered that I have a number of different features that I have enabled on my network. So I have BGP, firewall, HSRP. I also have a set of key CLI commands that I can utilize, NTP, OSPF, and so forth, that are pertinent to the devices on this particular map. And within each, I can see a history of when the state has turned green or red. In this case, I have some reds. I can see that a BGP neighbor check in core P01 has an alert. I can click into it, and just like before, the automation can give us a lot more information as to what happened. So here it says BGP neighbor has changed, current versus baseline, 4 rows have changed, and here are the different rows that are changed. I can click into it and provide more details. So now, quickly, I can see what the current BGP table looks like, neighbor table looks like, as well as what the baseline is and what's changed. And in this case, I have table version that has changed. So that means a BGP routing has changed, the tables have changed, or something within it has changed that may be related to the issues or the things that I'm trying to troubleshoot or the things I'm looking to assess, right? So this allows us to break down any particular network into the two states of golden configuration, golden intent, and expose all of this onto the map itself. So how do we do this? So how do we're able to build all of this? And this is introducing something that we call in R12, a golden engineering studio. So the first is the golden config browser. So in this case, we have lots and lots of different rules that have been reverse engineered from the network itself. And now you can see here from QoS, HSRP, failover, NTP, security rules, switching rules, system rules, all kinds of different rules. Now, within each of them, we can now see what the golden configurations are, as well as what alerts are now exist within the devices itself. And I can furthermore see that I have over about 100 different configuration templates that apply to 77 devices, and I can see a series of SEV1, SEV2, and SEV3 alerts, as well as lots of these rules are actually compliant. So let's actually dig down and actually try to build a rule together, just to show you how this kind of works. So let me build a new rule. In this case, I'm going to build a new rule that's called NTP server, and I'm going to put my name into it so that I avoid any confusion. Now, the first thing I'm going to do is I'm going to teach NetBrain what an NTP server configuration is. So first, what I'm going to do is I'm going to go and pick a device that I'm going to use as a representative device that I know that currently has NTP configuration onto it. So let me actually just dive down. I can see here, great, NTP server 10.10.0.101, preferred version 3, NTP server 10.10.10, 10.10.0.102, version 3, great. So now what I'm going to do is I'm going to teach NetBrain that NTP server, this is the NTP configuration. So I'm going to use my trusty visual parser. And what I'm going to do is I'm going to say parse lines. And I'm going to parse all the lines that have NTP server as part of the configuration. So very quickly, NetBrain is able to, I'm going to call this NTP server config. And anything that contains NTP server, I'm able to now pull it back and put it into a configuration. So this is great. So I'm going to click OK. And now you can see that I'm able to now say, hey, the thing that I just taught NetBrain to do is to teach what an NTP configuration is. I'm going to add it. I'm going to set it as a target configuration, as this is the thing that I'm going to use to discover my network for variations. So I'm going to save this. And then I'm going to go into my my step of discovering my network. So as part of the Golden Engineering Studio, we have a capability to reverse engineer the number of variations. And remember, we talked about what questions do we want to answer is how many variations of NTP server is there currently in my network? So now what I'm going to do is I'm going to add now a bunch of devices, and I'm going to go into my Cisco iOS devices. I'm going to add all of them. And then what I'm going to do is I'm just going to calculate. And what this does is NetBrain uses what I just taught NetBrain what an NTP server is, configuration. I'm going to go ahead and actually try to see how many variations of NTP server configurations are there in my network in these 42 devices. So very quickly, you can see that I have found 3 variations. Now, the first one that I can click into is understand now that this is from LAX, SFO, so it looks like my California, or at least my Americas devices. My second one consists of London and Munich and various different devices. So it looks like my EMEA devices. And then my third is my Singapore and Japan devices. So these ones will naturally have a different NTP server that exists in different subnets that it's local to the devices itself. So this is great. So now if I look at this, I can say, okay, so now I understand that there are 3 different variations. All of them look like to be real. And now I can actually click all of them. and I'm going to say, I'm going to add it to a golden config parameter. I'm going to call this parameter NTP server by region, put my name to it, and I'm going to click OK. So now is a chance for me to, now I just used fact-based uh, reverse engineering to understand what different types of configurations and variations I have in my network. Now you can imagine when we run it into a non-lab environment like mine, is that we could potentially find lots of variation, and there could be lots of them that should not be a golden. Right, but in this case, what I'm going to do is I'm going to say, well, 10.10.0.101, this one actually should be applied to devices within the region America. 10.20.0.101 is going to be matches EMEA, and 10.30.101 is going to be matching APAC. So I'm going to save this. And I'm going to go back to my particular NTP server configuration that I'm just using. And now what I want to do is I'm going to add back that represented device. So the device that I use, I think, is switch 1. To retrieve the configuration. And now what I can do is I can now define what a golden configuration should be. So here, because I used LAX switch 1, this already has the configuration filled in. But what I'm going to do is I'm going to delete this. Instead of having a static configuration, I'm going to insert the variable that I just used. I'm going to attach this one that basically says NTP server region song. I'm going to insert it, and I'm going to apply this to the devices that we had just utilized. So it's all of my Cisco iOS devices. And that's it. So I'm going to hit test quickly. And now what we should do is it's now going to go run against those 42 devices using the forward engineered and reverse and forward engineered golden configuration template that I have defined to say 1010 should be in for my Americas and et cetera, et cetera. So I can see very quickly there are 2 alerts. And I can jump down, I can see, well, London, I actually don't have NTP server configured, but it should be 1020.101. Beautiful. And then I can see my LX switched. I should have 10.10.0.101, but it's also empty. So this allows us to use a very simple couple steps to, 1, reverse engineer the different variations that of configuration in your network. 2, forward define what the configuration should be based on different devices and rules that you have. And 3, very quickly test this so that we can actually now start to identify day 1 issues right away. All right, beautiful. So now the second part of what we talked about is the intent, is the state. So now if I can jump into my golden intent, you can see that I have a number of different features that I've understood from my network. I see that my network has BGP, EIGRP, different types of failover configurations, HSRP, NTP, and so forth that are now prevalent and present in my network itself. Now, when NetBrain reverse engineers this, we understand a couple of different things. Number one is understanding what devices currently have BGP configured if I click into the BGP feature table. And furthermore, I have a number of different intents now that are now attached and diagnoses are attached to this. So I can see from core P01, I have a BGP neighbor check configuration or the state. It's red. I can click into it, look into the state, and this is what's actually populating what I see now on the map. So within the golden intents, we're able to now reverse engineer the different features that exist within the network itself, and now apply different types of states in the form of automation that are intents, apply to all these devices and make it available in a table, but also available on the map while you're using and troubleshooting it. Awesome. So this is just a sneak peek of the different items that we have in the reverse engineering. So just to summarize, instead of building all of these automations bit by bit, defining exactly what the goldens are, we're now able to use the Golden Engineering Studio to speed this all up and using a fact-based data-driven model to look at what variations of configuration do you actually have in your network, reverse engineer it, and then be able to give you that ability to define a golden using a configuration that you already have in your environment. The second is decoding and reverse engineering the different features that you have in your environment, the devices that are associated with them, and then attach different types of state checks that you can start to use immediately to understand whether or not there are issues that exist in the network today. Great. So let me jump back into my PowerPoint, and let's dive into the second piece of our discussion of R12 is proactive remediation. So up to this point, maybe just a little bit back into a couple years of our evolution of the network intent. Network intent is, for us, is a no-code automation unit that's able to capture any context or intent that you have in your network. So this is a very flexible way to define what device, what data, and what observability logic that you want to capture in your network. So now this applies to configuration, this applies to CLI commands, APIs. You're able to very flexibly, through a no-code automation platform, define what to observe and what data to use to observe and what diagnosis logic to observe. And then in 2022, our product innovated, and to develop into that, we're able to now take any intent that we capture and replicate it across your entire network. So you may say that, well, I want to check for BGP ACL asymmetry, and first I'm going to capture it on R1 and R2. And now I'm going to actually replicate this across all the devices that have potentially BGP on it. And then late last year, we introduced our summary dashboards that allows us to use all of these intents in any of these our typical network workflows. So it could be for troubleshooting, it could be for change, but also it could be for these network-wide observability. So observability roots from the context and the intents that it's able to capture, replicate them across the entire network. Now we can observe them at scale. So a lot of our customers have used this capability to proactively look for potential issues that could cause outages in their network, and they've been very, very successful. But now in 2024, and a lot of customers have been asking this, is now we see all these issues. Can you help me remediate them? And now this is exactly what we've been able to build into our automation unit. Is not only can we capture, we replicate it, we can observe it, but based on the different alerts, we can now go and remediate proactively into the automation itself. So this will help us complete our vision of going from observability to action to remediation. So from an observability standpoint, the intents should be able to help you with observing any types of task. So it could be for troubleshooting or change. And it could help with network-wide observability, such as security zones, failover, config drift, critical applications, looking across your network for your daily health glance of what could potentially go wrong. Each of these observability can now tie to a particular remediation task. So for security, it could be that, hey, I'm finding something that an unsafe interface, I want to shut it down. For failover, I can see that something is stuck. I need to force failover. For compliance reasons, I could see that, hey, all the golden configurations that we just saw, I want to now remediate them and set them to golden. For performance, I could see that I have a potential performance issue, and I need to change some of the parameters in QoS so that I can actually go and remediate it. So lots and lots of automation and the assurance and diagnosis can now lead to finally action. And this will help our customers remediate faster, reduce MTTR, prevent problems, reduce security risks. So let's take a look at what this looks like inside the product itself. So I'm going to actually jump back into the product, and I'm going to start with a dashboard I built that's called Network at a Glance at an executive level. So this is our network-wide observability platform in which we can summarize all the automations together and help to provide network-wide to see what devices could potentially have issues, as well as where they are in the world. So I scroll down just a little bit. you can see that I'm actually looking at across a number of different vectors. I could be looking at compliance. I could be looking at config drift, critical applications. I could be looking at past outages. So every single time a outages or a root cause has been found, I build automation to now observe it continuously across the board. I can be looking at my routing, security, what's changed. So now up to this point, we talked a lot about golden configuration. So let's actually look at that config drift by region. So let me deep dive into this. And I can see immediately that this is split up by the different regions of my network. So I have America, EMEA, and APAC. Now, remember, I have all the different types of rules that are reverse engineered from my previous example that now I've built into my environment. So I can click into here and see that all of it is here. So static routing, STP, SNMP, interface bandwidth, firewall, NTP server, and et cetera. And I can immediately see that I have a couple of different alerts based on different severity levels. And let me click into severity level 3, and I can see that now LAX SW06, so one of the devices that we found before when we did the golden engineering, has an alert. So I can now from here immediately drill down into the map to look at it, but also I can just take a look at the intent itself. Now with this intent, not only is it able to now see that it does not match with the golden rule, let me just run it again. And this time it will pop up now with the power of our R12, it will pop up a pop-up box that says remediation. So now you can see that it automatically says, this is the device, LAX SW06, and here's the change command potentially of that what we can do now to remediate the issue. So you can see here that it's automatically populating the golden configuration that I have set it as 10.10.0.101 and 10.10.0.102. And if I click yes, what this will now do is automatically create a change item that pre-populates LAX SW06 with the configuration. And we can benchmark before, benchmark after the execution. So it's the change flow that we all know and love. So now let me actually just go in and let's say I want to actually now submit for this for approval. So I'm going to ask myself, to in webinar, please approve if I can spell right. And don't try this at home, but we're going to approve this right away. Bang. So now this is approved. I can now do a benchmark before. Let me actually just run this to just collect the configuration file. Great. And now I have fully retrieved. Now I can actually execute this. So now I can see that conft NTP server, and I can now execute it using the information that I've collected from my golden configuration. I pre-populated this automatically because I know what the golden configuration is for LAX SW01. Let me just click into this and see I've completed the remediation. Let me do a quick benchmark after. And now I can compare between new and live. So I'm going to hit compare across the different devices. And I see from my configuration file, okay, benchmark before, benchmark after. Let me just actually validate this a little bit. I can compare the same device instead of the current baseline. I'm going to compare before and after the change. Apologies, everyone. And now I can actually see that my configuration file has changed. So I can see that 2 has changed, and now I've added NTP server. Not only that, remember that I have access to golden configuration within my environment. So Now I can come here, verify, and now my NTP server config alert, if everything goes well, should turn green. Great. So now I have two alerts, 42 compliance, and now that's gone. So now I've just successfully turned that one red into a green. Awesome. So now our intent has that capability to not only be able to provide diagnosis towards assurance and letting us know whether or not a potential issue is there, we can now use it to auto remediate the issue itself. So let's jump back. And that was the demo. And let's jump into our last topic for the webinar today, which is what we are, and I'm really excited about, is we introduced for the first time generative AI into our product. And our vision for this is truly is a human interface to all the machine intelligence. So we have lots and lots of data, automation, diagnosis, insights within the NetBrain itself. One of the things that's always been a vision for us is to continuously make this as simple as possible. And we're very excited now, after many, many years of testing and building and innovating, is the new advent of generative AI really allows us to take this to the next level. So generative AI, for us, is a human interface to the machine intelligence and all the powers of NetBrain. And we think about this value in three key steps. First is we want to make it so that you can ask generative AI all kinds of different questions. Now, first is it could be in an advice capacity. So you can ask it things like, how do I troubleshoot BGP issues? And this will utilize the generative machine models or the large language models that lots and lots of capabilities have been built. And we see a lot of this now within the public realm, is to you pull that generative knowledge into NetBrain itself. Now, the beauty of this is so for example, if we can ask it, for example, how to troubleshoot BGP issues, it should be able to use this model to actually give us a number of different steps. Now, NetBrain has access to the network itself. So the second thing we envision is that it should utilize, we should be able to utilize Gen AI to orchestrate automation. So we can say then things like, please run these above steps of how to troubleshoot BGP on US Boss R1. And immediately, because the Gen AI should have access to the powers of the digital twin, the live access and the intents and the automation that we now built into now executing this on your live network. And then because of the Gen AI's capability of large language models, a beautiful part of it is that it's able to go and summarize all these results. So instead of clicking and looking at the alerts one by one, while you still can and be looking at it from a live raw data and diagnosis level, we envision that it should be able to summarize all of this for you so that it can provide for you a tangible next step, right? So this is very, very exciting for us. And for the first time, what I want to do is jump back into the product one last time and to show you this. So let me open up just a new map. And now within NetBrain R12, you'll see that there's a new tab that's called AI Bot on the top left corner. So if I click it, I'm going to save this map. Now you have a language chat interface to the rest of NetBrain. So let's actually just use the example that we just showed in the slides and just say, let's say, for example, I'm trying to troubleshoot a BGP issue. And how do I troubleshoot BGP? So as I ask this, NetBrain will have access to a general AI model, a large language model that's been built by the public domain that's looking at basically how do I troubleshoot BGP. So here, for example, I can see to troubleshoot BGP, you can follow the below steps. And it summarizes also with the different commands that it has for me. So very interesting. Now, I want to say is please run the above steps on US Boss R1 and draw the device on the map. So this now gets into our orchestrate section. Is it now draws the device on the map, And what it's now going to try to do is execute the above steps of how to troubleshoot BGP on this device itself. So it's utilizing now the powers of NetBrain and the variety of different tools that NetBrain has to access your live network to be able to try to do this. So it's taking a little bit, understanding what to do, and it will now execute on the live environment. Probably need to just cut this part out a little bit in the webinar itself. Great. So now we can start to see it's running some commands on the US boss RW or our US boss R1. And I can actually see basically what the original data is. So for example, it's retrieving show IP BGP summary, show IP BGP, looking at the routes. It's looking at logging and show IP route. Okay, great. So now I can see that it's found some stuff, right? So it's looking to say, I have, here's my BGP neighbor table, my BGP routes, my logging, so on and so forth. And at the very end, it's actually able to how to summarize into some of the key insights. So let's take a look at this. So idle neighbors 6789 and 172.16.253.9 is an idle state. So there's a potential connectivity issue. Very interesting. It also found that there's multiple duplex mismatches detected on interfaces through my logging. And I can see that there's high activity with established neighbors, right? So that's good, but the idle states needs to be addressed. Beautiful. Okay. So this is already telling me a lot. Now what I can do is I can now, let's say, I need to escalate this because I'm a level 1 and I may not know exactly what to do with an idle state. And it looks like there's a connectivity issue. Please summarize the above into an escalation email I can send. So utilizing the powers of utilizing the powers of the summary capabilities within NetBrain, with generative AI, we're able to take what's been now done, what's been found, and now summarize this into an email. So, dear team, I'm reaching out to escalate an issue on US Boss R1. Here's the raw data. Here's the key issues identified. Here's, by the way, additional information. And then I recommend a further investigation into idle BGP neighbors. Beautiful. So as all of it, I can just copy paste this, put my name, my position, and I'll be able to send it down this merry way, and then we can address much more things. So because of time today, there's a lot of really, really interesting things that we can do with generative AI. I really advise and encourage everyone that's interested to get a demo with us where one of our engineers can really dive into this more detail and then also get upgraded. So let me jump back into my slides one last time. And I want to come back and thank everyone for attending this particular webinar. That's super exciting for us. R12 is all about systematically shifting left using the fusion of automation and AI. So automation through no code, build the intelligence and diagnosis within the network. And then we have the AI that provides that no barrier access to all the automation capabilities on top of the digital twin. So R12 is available for all our customers today. So please follow this link and to actually request an upgrade if you're currently a customer. And there's some data sheets to help you learn more, but also please feel free to visit us at netbrain.com and request a demo to see furthermore into a lot more of what we can do. So with that, that concludes the webinar today. And with that, I'd like to pass it back to Ryan. Thank you.
Amazing song. Hey, thank you so much for your walkthroughs. And of course, these use cases are critical. I want to also thank Raj Jain, one of our engineering leaders, for being on the call, of course, to answer questions. Many of those questions have already been answered. If you have more, definitely put them in the chat or email us afterwards. We're going to have you out of here by the top of the hour here, but just wanted to share a few final takeaways. Of course, where does the rubber meet the road with R12? It is in case studies, right? Here's a consumer goods giant with our preventative automation. Now with AI, was able to save $300,000 in their first year with 99% MTTR reduction. They didn't have to manually check all their devices for a telnet vulnerability and saved 499 hours of audit time. Here's a large infrastructure org with hybrid network visibility, 18,000 devices, 60,000 changes a year with outdated maps. They were able to save 16,000 hours in no more failed compliance audits. And then, of course, in slow troubleshooting previously, 3.2 million is their number, not ours, compliant and secure. You mentioned that AI piece, right? AI and humans, right? We don't want to get rid of either side. We need AI and human interaction. Here's how that works, right? Asking those questions in natural language, that LLM, OpenAI can be turned off or on, but of course, leverage it for your use case. And then it powers that automation. It orchestrates that automation. It allows you to set up compliance checks, remediation, and integrations, of course, across your hybrid network. Really, where this comes down to oftentimes is the same problems repeating themselves over and over again. 50% of this customer's tickets could have been remediated, prevented even, and then 95% automated for prevention. Why not make that reality for you next year? Of course, those action plans, you'll see more about this in upcoming releases. We have a whole library of intelligence and action plan automations to help you set up that proactive automation at scale. So what are we looking at? Live network discovery, reverse engineering to config rules and network state, and then of course, building that automation, all powered by NetBrains' live mapping, digital twin, no code automation platform. Getting, of course, observability to action to remediation. And then I want to mention our robust integrations. Some of you are saying, I got so many tools. How can I add another one? Multi-vendor integration, my friends. Automation with Splunk for your SIEM, ServiceNow for your ITSM, monitoring, app and packet tools across AWS, all the different clouds, private, public, Azure, Google Cloud, Cisco. Of course, utilize your security tools. We have one large electric vehicle manufacturer customer who tells us, if it's not NetBrain data, we don't want to see it. NetBrain data helps all the other systems make more sense. And as a final point, accelerate those outcomes, right? Observability, secure chains, troubleshooting, and prevention. I want to invite you, of course, to continue the conversation, get a demo. We also have these live experience labs we're running Monday through Thursday. We'll pick them up after the holidays again. We want to encourage everybody. You can actually get a login, and in a demo environment, you can play around with it yourself. Absolutely free, no contract needed, no nothing. Basically, come get a login in a secure environment and test these things and make sure that you can realize these outcomes for your own organization. All right, with that, I want to wish everybody a very, very happy holidays. Again, I want to thank Song Peng, Head of Engineering, and Raj Jain, a great leader for us. Continue to keep the conversation going, netbrain.com. And again, this webinar will be recorded and sent via email. So thanks so much, team. Have a fantastic rest of your holiday.